Good morning, my fellow South Africans. I addressed you as we did, well, as the President affectionately does to us each day. But good morning to all of you, and to you, Gerrit, thank you so much for joining us.
And thank you for Voltex for the opportunity to have us do this webinar. It's the first kind, so we're learning as we go along. I'm looking forward to it.
Oh, us too. For the people that are joining us for the first time today, I am Robin from the Voltex Marketing Department, and today we are joined by Comtest and Gerrit here to present to us. And he has a really awesome presentation going, and I'm looking forward to handing over to him soon. Just a couple of house rules, I guess, from my side, is we will be having a Q&A session after the presentation, so please do feel free to leave any questions that you might have in the chat section, and we will address them after Gerrit is done with his presentation. There will be a replay link made available after the presentation, so should you have any issues with your browser or connection, as we do in these technological days, either refresh or just hang tight for that replay link that will be sent to everyone that registered later today. And yeah, all the Comtest and in particular Fluke products are available through the Voltex branch network and on our online store. So please do feel free to visit one of our branches or get in touch with us via one of our many platforms, whether it's on our website, social media, or our recently launched WhatsApp line. But that's it from me, and I'm going to hand over to you, Gerrit.
Thank you, Robin.
We'll start the presentation for you.
Good morning, everyone. Gerrit from Comtest. I'll be talking about battery testing and reporting. We're going to try and see if we can do this not too technical, but more of an informative session. So we'll have the questions afterwards, as Robin informed us. Just about myself, I've been with Comtest for the last 11 years. I've a qualified electrician as a background, and that's helped me a lot with the customers in our industry. And I'm also level 2 thermography certified. That was done via the Introspection Institute. And you have my email address at the bottom, should you want to make note of that for any queries or questions related to what I'm presenting during the course. Just about Comtest. Comtest, we provide test and measurement, communication, process control equipment, solutions, and specialized systems from world-leading manufacturers to the Southern African market. We're committed to service excellence. Comtest service promise to offer smooth implementation of your systems with high level of maintenance and support using experienced staff. As required, whilst keeping customers' test and measurement communication process and calibration equipment at consistently high levels of operation and accuracy. Comtest has been servicing the industry for over 15 years, and I've been with Comtest 11 years. So, yeah, quite a long time, and a lot of experience and wealth of knowledge during that period. Just our agenda, battery definition. Talking about flooded lead-acid batteries, your valve-regulated lead-acid batteries, battery installation environment, how batteries are connected, why test batteries, battery failures, battery resistance, and how to test batteries and report. So please just take note, I have made reference to our Fluke and Medtronic battery testers within our group, because I have access to these at our office. And yeah, we can always make an appointment later after the webinar, just to see if you guys are interested to view these products. All right, so let's get into it. Battery definitions. Batteries come in all shapes and sizes. Rather than giving batteries unique names, as we do with other bits, we distinguish batteries by chemistry, voltage, size, specific energy capacity, specific power, delivery of power, etc. So that's quite a mouthful in that first sentence, but yeah, batteries are not as simple as we think. A battery can operate as a single cell to power a cellular phone, and we all know back in the old days when we had to do a BlackBerry hard reset, we had to remove the battery from the telephone to reboot it. All right, so nowadays the phone's a lot better. We're not playing with that problem anymore. Okay, so batteries can be connected in a series to deliver several hundred volts to serve an uninterruptible power supply or UPS, or the electric powertrain of a vehicle. Electric vehicles or EVs are becoming more popular every day. Some batteries have high capacity but cannot deliver much power, whilst your starter battery has a relative low capacity but can crank your engine with up to 300 amps of power. So when we look at the most common battery that we are seeing in the industry, that will be your flooded lead acid battery, meaning that the battery's got liquid acid inside, and that will allow it to then do what it does. Your flooded lead acid batteries are the most popular type in use today. They are used in many different applications. The term flooded refers to the battery having an excess of electrolyte fluid inside. The plates are completely submerged. The electrolyte level should always be above the top of the plates. So you'll see you have your plates in the image, you'll have your plates submerged, and that will be then covered by the electrolyte. This serves as a reservoir to ensure that the water loss during charging does not go lower than the plate tops and cause damage. So these are the most common batteries, and they're very popular. There are a lot more modern technology, different technologies, but I'm going to just focus on certain technologies for this purpose. So what are the advantages? So your flooded lead acid battery has got a lower cost than your valve regulated lead acid batteries. Got a longer life. It can be maintained by addition of distilled water only, more available worldwide, and performs better in hot climates. Disadvantages: you need to periodically maintain these batteries by adding distilled water. You can only be used in an upright position because they are filled with the electrolyte. They produce gas or oxygen and hydrogen when charged, so we need ventilation while recharging these batteries. And we cannot ship them by air for obvious reasons. Valve-regulated lead-acid batteries. Right, so if you look at the bottom left-hand corner image, you'll see that's the most popular one. A lot of you might have come across these for alarm systems, electric fences. You're going to look at different applications for electronic equipment. And of course, yeah, then they're very popular for their size. So valve-regulated acid batteries were developed in the late 1960s to eliminate the need for water, in addition, and to provide batteries that could be used in any position. So there's already an advantage of this type of battery. We don't have to keep them upright. VRLA batteries are preferred in installations where access is difficult or space is limited. Their ability to be operated in any position allows them to be used in spaces where flooded batteries cannot be used. Typical battery installation. So if we look at the images that are on the screen at the moment, you will see a typical battery rack with lots of batteries. The image in the middle refers to a different scenario where we have your automotive batteries, and we can test them as well. So we are talking about these two types of batteries for this application today. And on the right, a different type of installation rack, and you can see there's many batteries, and each and every battery needs to be tested. So if we have any questions on these, we can list them just later during our questions afterwards. So when we look at this type of battery installation, different sizes and shapes. For automotive, you'll have your smaller, relatively smaller batteries for your petrol engines, and then your diesel engines will have a way larger battery for higher cranking capacity due to the compression of your engine. So it makes sense that the diesel vehicles will have larger size batteries. In a truck scenario, your truck will have basically two 12-volt batteries connected in series, and they will then be connected up to give you 24 volts, which is the operating system of a normal truck. When we look at the middle image with automotive testing, we can test the battery system, the charging system with the lights while it's on load, and you have the ability to actually print a slip. that will then tell you the condition of the battery. So this makes it very convenient for portable applications or automotive, where the customer needs to have printed evidence of the results. The next image refers to a typical battery installation and what we could see there. So you can have multiple rows of batteries, sometimes 60 or more batteries in a string. Those batteries will then be connected by links or straps, depending on what you want to call them, and they will then join these batteries into in a series configuration to give you higher DC output voltages. When batteries are connected in this configuration, you can see there's a large amount of batteries and the risks are potential, so always adhere to safety standards, wearing the correct PPE when testing batteries. So why do maintenance-free batteries need maintenance? Compared to your non-maintenance-free open-flooded battery, the valve-regulated lead-acid battery does not need to be topped up with distilled water periodically. Maintenance-free batteries need to be tested because they deteriorate in several failure modes. So the first one that we're mentioning in the diagram here is corrosion, an internal short within the plates, and then sulfation. Sulfation is happening onto the plates when the batteries are decharging, and you can have special desulfating charges that will recondition your batteries to actually recover from this condition. Batteries dry out, you have seal failure, and that will cause your battery to swell, and that can cause it then to actually push out of its enclosure or casing and cause other side effects as well. Then you have your catastrophic battery accidents due to careless maintenance. Okay, so let me see. Is everything okay there? All right, so catastrophic battery failures will mean the batteries will just explode. They can catch fire or they can swell, and they can actually then just completely fail and leave you in the dark or without power, depending on the application. Something that is not in this slide here is the fact that also when you have no batteries there, that would be theft. It's a problem in South Africa, it's real. Your cellular towers, all of those guys, they steal these batteries, and security is always a concern as well. So just mentioning theft because it's part of keeping the power on. So what affects a battery? Low temperatures slow down the internal chemical reactions in any battery. If a battery room's ambient temperature is higher than 25 degrees Celsius, the floating current demand on your charger will be doubled for every 10 degrees Celsius increase in the electrolyte temperature. So when we have all of those batteries on standby, we have a charger that is topping them up to keep them at the optimum charge level. So if the temperature rises, the floating current will need to be increased. The increase in your float current causes excessive wear on the plates and shortens your battery life. So there's a side effect on that. For every 10 degrees Celsius increase in battery temperature, the battery life is halved. So that's another consideration. So these battery rooms where these racks are installed will need to be temperature controlled as well. So part of maintaining your batteries would also be the ventilation and the air conditioning. Battery degradation. The main cause of battery failure is heat. For every 10 degrees Celsius average temperature, battery life is halved. Causes the electrolyte to be expelled from the battery. It degrades the plates, the anode and cathode in your battery. Overcharging, sulfation. It turns lead oxide into crystal form, and these attach to the plates, effectively lessening the capacity they are capable of delivering. Shedding and grit corrosion. Lead oxide falls off the plates and can be caused by overcharging and vibration, shaking the batteries and bumping them, etc. And then corrosion caused by not maintaining charge. The batteries will fail if they discharge. So we need to keep this in mind. So at the bottom, these effects tend to increase the internal cell resistance or impedance. This gives an intro to where we're heading with this. Why do maintenance-free batteries fail? Thermal runaway, they get too hot. Loose terminal and inter-cell connections. Overcharge and over-discharge. Ripple will relate to your charging system. If you don't have a pure DC system charging your batteries, that could also cause it to fail. And then at the age of the batteries, that has a big effect as well on the longevity and the performance. What happens when one battery in a string fails? If a single battery or cell goes open, the whole entire string goes offline and the load is no longer supported. This means that we can have 60 batteries, only one of them needs to fail and the whole system is down. One battery will affect the usable life of the adjacent batteries by raising their charge voltage due to the charger setting. So obviously, if one battery fails, the charger is bypassing and it will then go into the next batteries, affecting their charge performance. A battery or interconnect with a high impedance could overheat, ignite, or explode during a discharge. So let's say the power's gone off, we're drawing power from our batteries under load, then these links or straps in between the battery cells that join them, they could fail and ignite and cause a fire. So we have fire hazards with batteries as well. Battery resistance and impedance. So what is battery resistance and impedance? Why we measure the internal resistance or impedance of the battery, and how to measure battery resistance and impedance, and when we measure it. So this image refers to what is actually happening inside a battery and what can be tested or measured. Battery resistance. What is battery resistance impedance? Let's differentiate between a pure resistance or resistor and impedance Z that includes reactive elements such as the coils and capacitors. Both values are given in ohms. So if we look at this image, it will show the construction of your battery. What we would find in a flooded lead acid battery, you will have the casing, you will have the electrolyte, you will have your plates, and the cells individually, and they're all joined into a series to give you 12 volts, for an example, in this battery scenario. Battery resistance. So when do we have to measure your battery system? IEEE recommended maintenance procedures will be as follows. So for your flooded batteries, we need to test the total voltage of your system monthly, the charger output current and voltage, ambient temperature and ventilation, visual inspection. Visual inspection is always a good way to also see what is happening into the installation. Electrolyte levels, so that would be the acid inside the batteries we need to check. Pilot cell voltage and specific gravity. And then quarterly, we need to check your specific gravity, the individual cell voltage, and then cell temperature. For your valve-regulated lead-acid batteries, total system voltage monthly, charger output current and voltage monthly, ambient temperature and ventilation also for monthly, and then visual inspection. Then quarterly, we will do the individual cell temperatures, the intercell connector resistance, and then, of course, when we look at biannual, we can do the individual cell voltage, and then annually, we can also check the interconnector resistance. Interconnector resistance is important because those links or straps are connecting these batteries in series, and we could have corrosion on the links or the joints where they are tied to the batteries themselves. So our traditional methods of testing your flooded lead acid batteries is by using specific gravity tests. This involves using the hydrometer that you can see on the image on the right hand side. This little pipette you would push into the cells, and then you would then test each cell for the charge state that we would then see based on a little floater inside the hydrometer telling us what the charge level is. So this is how traditionally we used to test the batteries. Problem with that test is it's time consuming. Each cell needs to be opened. So physically, each and every little plug cell where the acid fills in needs to be opened, and you need access inside. You'll have to insert this hydrometer into each cell, and the values needs to be written down manually. So every time you do the test, you have to write that down on a piece of paper. Gases from the cells charging causes health risks, and acid-resistant gloves need to be worn because we are opening the battery and we have access to the acid inside. So there's risks with that. Modern ways to test the batteries. We use proprietary algorithms to utilize multiple conductance measurements, battery temperature, and voltage to provide a detailed picture of a battery's performance and predict when it's nearing the end of life. Fast, quick, and safe with date and timestamps, and it allows for trending of test results over time electronically. So in this slide, if we have a look at the graph in the middle, it is so easy to see which batteries are failing. Just by looking at that picture, it's a quick overview of what's happening. So in that case, each and every battery in those strings were tested individually, and for argument's sake, battery number 15, you can see that the internal resistance is different than the rest. So we are comparing likeness for likeness. All the cells should have the same chemical composition and resistance values, but those batteries are standing out compared to the rest. So this allows you to identify which cell or battery is actually failing, and we can then plan a shutdown to repair or replace those batteries by quickly seeing where those batteries are faulty, which numbers. You as a user will only have to number the batteries, and then the instruments will do the rest for you. So this is a slide that shows the easy setup. Electronic testers makes it quick and convenient to input battery bank information, the number of cells, etc. So if you look on the image on the right hand side, is your site name, the device name, the ID battery string, and how many batteries we have. It will show you how many we've tested and what the capacity of the batteries are. Now bear in mind that we are not comparing these batteries to a database of batteries to see if they are good or not. We are actually testing these cells or batteries individually, comparing likeness for likeness. So this makes it very easy when we have similar batteries in a string to compare. Once all of our cell values are recorded and saved, you will then download this data into your software to create a report. All right. So if you look at the bottom right-hand image, you will see that there were 32 battery cells. It will give us the average of 2.64 milliohms, and the average voltage for all of the battery cells in the string was 13.21 volts DC. Now bear in mind, this is not a sequence test. Each individual battery is numbered, and it's an individual test. Should battery test number 8 fail, I can just quickly, conveniently retest it. Okay. So the products that we used for reference in this image is the Fluke BT500 series. So you'll see it's similar fashion to a multimeter style. This will allow us to measure the voltage, the current on the load, the ripple voltage, and test the values and save them with date and timestamp for reporting. Very quick and easy to operate and safe. And then we have the Medtronic CPX series. It's a handheld system that puts load onto your battery, and it will give you system capacity or reserve with a printout slip. The image on the right hand side is a more portable one for automotive, quickly giving you a printout right on site by your vehicle, quick and conveniently. We have a question of how does the current stock levels look like in South Africa? Yeah, Comtest has got stock of the Medtronic items and the Fluke batteries available for purchase through the Voltex group. Just some references. Eskom DC section, they has approved this since the last 2 years for the Fluke BT521 series. This was tested and came out tops against all of the manufacturers' battery testing systems available in the market. So it's quite nice that they found this one to be very suitable for the applications. It's easy to use. Impala Mines in Rustenburg, they used the BT521 series as well for their standby batteries in their substations. And then we got RT Systems, they do UPS installations and maintenance. They're also using the Fluke version. And then on Medtronics, we have them approved by Willard Batteries. AA is also using the Medtronics portable testers for the vehicles to test and report on the batteries in the cars. And then also BMW South Africa, they are using the Medtronic battery testers and solutions and power supplies. When we say power supplies, that would mean that in the Medtronic range, they also have portable power supplies that enables you to keep your vehicle powered while doing software upgrades, for instance. So if your software update in your vehicle fails due to flat batteries, you will then have a severe failure on your system. So we can't have that. And that takes us to the last slide, which is our questions. Thank you for your attention.
Thank you so much, Gerrit. That was really informative. I have a couple of questions come through. I see you did answer the one regarding the current stock levels in South Africa. Just to reiterate that there is stock available through Comtest and Voltex. I've got a couple of questions here. It says, where are the batteries manufactured in general?
So Willard Batteries, for instance, they manufactured locally by what's a group, PowerTech. So that's locally manufactured. And of course, there's a lot of import batteries, so it's difficult to say where they're manufactured. There are so many brands available in the market. Even if you look at an example out of experience, the Midas Gold version batteries for the automotive application, they are actually also supplied by Willard.
Okay.
Just branded differently.
Thank you. I see a few more questions coming in here. Please do feel free to send in your questions. There's a question here from Kevin. He says, what's the price of the Fluke meter?
Okay, so the list pricing on the Fluke battery tester depends on the model. There are 3 models with basic functions. The BT521 being the top of the range will give you 1,000 volts AC and DC testing and current testing, and the ones below that will not give current testing but up to 600 volts. So we're looking at roughly about 80,000 Rand for the top of the range one and 60,000 for the entry level model in the Fluke range.
Thank you. And I see a question here from Mr. Swart. He says, we use NICD batteries in our BTUs. Can you test them with the same equipment that you use for lead acid?
Yes, you can, because we are measuring the internal impedance or resistance of the battery. So it's purely the chemical composition of the batteries that actually is being tested rather than the capacity of the battery. So the idea is to actually identify which battery is different to the rest.
I see. I see another question here for the cost of the Fluke 521.
All right, the 521, we were saying it's around about 80,000.
Great. And what are the basic requirements for a battery charge room?
Okay, so battery charge room, that would be around health and safety, the area, the access to the batteries, ventilation, etc. What batteries are put in there, and then of course we need to have the temperature regulated as well. So that would fall under the regulations, and I don't have information on that to actually give a proper answer on that, unfortunately.
All right. A question here from Melissa says, do we need gloves for all testing, and are these gloves available at any Voltex branch?
Those gloves definitely a requirement. We are working with acid and high voltage DC voltages. The batteries are connected in series, so An electrical insulated glove and acid resistant would also be beneficial, and that would be available from Voltex.
Fantastic. And a question here saying, will this Fluke work on lithium-ion batteries?
I need to get back to you on that one. I haven't tested it myself, so I don't have an answer for that.
Okay, no problem there. Another question is, will this tester work on supercapacitors?
Don't know. Unfortunately, it's new technology. We're getting there.
We'll have to test.
What I can offer is actually, if they want, we can make a unit available and we can test it to see what it does.
Got you.
So I am available for on-site demonstrations if they'd like to see the instrument in action.
That's great. Question here, just can I listen to a repeat of the battery webinar? Absolutely, there will be a replay made available to anyone who registered for this webinar, as well as the link will be made available on YouTube. So just hang on for a little bit later today. Another question is, what is the warranty on battery testing equipment?
Okay, with the Fluke battery testing equipment, we have a 2-year warranty, and on the Medtronics, it's a 1-year warranty.
Thank you for that. If there's any other questions, please do send them through now. But just while we've got a little gap, I'd just like to say thank you so much, Gerrit, for that presentation. As mentioned, there will be a replay link made available for the session. And please do stay tuned to the Voltex social media pages, as well as our website for future webinars that we have. We've got a few more exciting ones coming up next week. And if there's anything you'd like to add from your side.
I would just say thank you, and it was a pleasure dealing with you guys, and I enjoyed doing the webinar. Any questions or regarding the products, if you need to send specifications, they're welcome to ask the Voltex guys. We can send you specs, PDFs, and pricing. We do have demo units available, so if you want to see the instrument in action before making a decision, we can do that as well. And then, of course, we have our support at Comtest, and with this instruments, the software is included at no additional cost, so that makes your value add so much easier.
I see we've had a couple more questions come through. We can address these. Does the testers reveal the CCA levels of batteries?
In the Medtronics ones, yes. The Medtronic one, you will actually put in the CCA values, it's called cranking amps, and it will test the battery's reserve or capacity based on the rating on the battery itself. And you can print that out. I can actually show you a slip of a printout if you maybe want to just show them there.
There we go.
So this is an example of a printout on the Medtronics tester, and it will give you the site, the date, the time, the information of the battery itself, and then it says it was a good value or not. The instrument for Medtronics is basically this size, so it is quite bulky relative to my hand, but this has internal load. It will actually test the battery under load and give you the reserve capacity of the battery, what is the expected lifespan of the battery itself, and this allows you to test it in vehicle or out of vehicle as well, with a built-in printer at the bottom. And that will just simply be connecting to the battery with crocodile clips. And then if we had to reference the Fluke one's more traditional style multimeter, and you will have your voltage test leads to conduct the tests and do the measurements from there. So the Fluke one will allow you to store the results and then download from memory and have a soft copy on your PC for later reporting as well. Thank you.
Thanks for those product demos. It's nice to see them firsthand. A question here from Richard saying, do you get a PSCC test done on Fluke meters?
What does the PSD stand for? Sorry for that. The acronyms.
Richard, if you could just let us know what PSCC stands for. We'll move on to Tay saying, can we do a webinar on image equipment? We can definitely look at that. Please do feel free to send any suggestions on what webinars you would like to see going forward. You can email those through to marketing@voltex.co.za. We would love your feedback. A question from Peter here is, what is the price of the Medtronics tester?
The Medtronics, depending on the model, there's different units available. In Medtronics, we'll have up to 7 different models available for different applications and functions. They could be anything from 50,000 Rand up to 100,000 Rand. Metronics also does online testing, so it's permanently fixed systems that you install into your batteries and you can remotely monitor them as well. So it's more than just what we've seen here today.
Oh, great. I see another question's come through is potential short circuit current.
Prospective short circuit current. All right, so with the Fluke one, it only tests the internal resistance of the battery and it will be up to a maximum cell voltage of 60 volts with the Fluke meter. Your prospective short circuit current will come with an installation tester. So Fluke will have that. We can look at the part number called the Fluke 1664 or 1663. That will do a prospective short circuit current, which will then tell you what is the maximum kiloampere rating in the event of a short.
And I think that is it for our questions today. So thank you again, Gerrit, and thank you to all of you for tuning in. And please do tune in with us again. I see one last question. We can take that and then we'll sign off. And it says, what is the cost of the collaboration after expiring of certificate issued?
Okay, so calibration will be done through RMS, Repair and Metrology Services. They are SANAS accredited, and calibration would be 2,000 Rand plus minus.
Fantastic. And that's all we have time for today, folks. But thank you so much for joining us. Thank you, Gerrit, again for that awesome presentation. And as I mentioned, stay tuned to the Voltex pages for future webinars. Signing on off from here, but thank you all. Take care and stay safe.